Let's get started. Any company update?
So we ordered. Is my volume good?
Oh, yes, I can hear you.
Cool. We ordered $1 million worth of 5090s, which doesn't get you
Great.
as many 5090s as you think it should, but the order's in. We have the first ones coming this week too, so we're going to build a $90 V2 with 5090s that we can start playing with.
That's a lot of
And
5090s.
I mean, we'll see if Justin comes through with the Intel deal. Is anyone interested in 15,000 Gaudi 2 cards? Look, I think it's unlikely. I think that it's if Intel was capable of doing things like this, they wouldn't be in the position that they're in right now. But we'll see. As long as I don't
Yeah,
have to do anything.
my impression is their Havana lab was pretty legit. They dissolved that, right? So
I mean, Intel has a long history of buying Nirvana, went to nothing, Habana, they're canceling Gaudi. The architecture is kind of upsetting too. The Gaudi architecture looks very hard to use. It's got a completely separate MATMO engine that isn't programmable from like the GPU light cores. So it would be software that doesn't really belong anywhere else. So look, if we can get a phenomenal deal on them, I'll take them. But I think that Gaudi is canceled, and there's a reason why it's canceled. There's just no way anything in Torch could have ever been fast.
okay, we're waiting on Intel. That's not likely to
Yeah,
happen.
we're
Okay.
waiting on Intel. It's not likely to happen, but I'm open to it if they really want to give me a phenomenal deal on things with lots of memory bandwidth and RAM.
Okay. Moving on to your stuff, DSP and quantize.
Yes, I've been making a lot of progress there. It's a lot of good refactors too. All that devectorized stuff is eventually what I want to move to. The later some things force you to devectorize. Like GPUs fundamentally force you pretty much to devectorize. There are no vector units in GPUs. But the more we can reason about vectorized, the faster it's going to be, and the simpler the graphs are going to look until you do this explosion where you blow it up to the expand. So yeah, working on the devectorized stuff. I have 2 kernels fast. I got 1 kernel up to 13 gigaflops. The biggest thing holding back the speed right now is getting pad to work, getting the pad optimization to work.
Work
So
on what?
I mean, it works, but
Yeah.
this is probably also why it's unbelievably slow on GPUs. The problem if you do a pad, all the consts become gated by that valid, even when you don't have to. So for example, if you pad with something, that pad, like if you have a load where it loads a 0 if it's invalid, and then you have a pad that is also applied to that load, it'll do another wear on any consts, even though you're basically, let's say it's a multiply, even though you're basically multiplying by 0. So the thing needs to be aware that like if it's already 0, you can just multiply by the other value and you don't need a second gate on that. I know what I have to do to write this, but that's just going to be the work next week.
Okay, great. I probably have open like 3 separate issues or PR attempts on this.
Yeah. So you've tried to fix this before.
Yeah, that was the whole point for the previous discussion for like rewriting the load into the where, but that doesn't really work. That's effectively to solve that. You can merge the valid.
To put the load into the where. Yeah, that's probably a good thing to do first. So there's like a bunch of refactors that the DSP stuff's kind of
Yeah,
bugging
yeah,
on.
because I noticed the same thing that say if you do a cat of bunch of stuff, it's a separate where for individual ones, but you can like combine them together.
Yeah, it's the same thing as cat, sure. Yeah, being able to reason about these wheres invalid with the loads, I think we can totally do that. I think that I think we talked about this last meeting. I know what the refactor has to be. We
Okay,
basically want
great.
to gate the load. We basically want to gate the load twice. We want to gate the
Mhm.
index to show that it'll never load from an invalid index, and then we want to gate the actual value of the load, and then all the normal value folding stuff will work.
Yes. We already have LED folding rules in place. Just you just need to use it.
Oh, great. So yeah, this is probably not gonna be that hard then. Yeah, a lot of it comes down to that. I'm through most of the quantized stuff. So if you look at my PR min quantize for DSP, it's basically two things. It's devectorized logic, which I want to make the default anyway, and it's quantization logic, which is just I learned about how quantization works and wrote like some basic stuff. Like in order to do this adjust, in order to like emulate a floating point thing, you do like a fixed point.
Mhm.
Yeah, like a fixed point. You can see the rewrite rule for it. So just getting those things tuned and to be right. It's just all the normal quantization stuff. I don't know how any of our quantization stuff is fast. It's probably not. We're probably just using floats and just the GPU happens to just be really fast at floats. So.
Yeah, so we have the NF4 quantize for Llama. That's very, very slow.
Oh yeah.
I think int A is probably fine, but we are not doing the block thing, so our int A is kind of broken too.
Well, yeah, I mean, even if like within a, uh, it's still going to give you the GPU memory bandwidth. So if you're doing batch size one, you are going to have the memory bandwidth if you have working int 8, even just on
Uh-huh.
the loads, even if the first thing it does is convert it back to float. But the DSP
Yeah,
can't convert it to float. So yeah,
cool. We got 6 weeks left.
yeah, it'll be doable. It's a good project. Everything about this is just like you have to get everything right to make the DSP work. Whereas with
Uh-huh.
GPUs, you can kind of they're so forgiving. Like there is nothing more forgiving than an NVIDIA GPU to get you performance no matter what. Their compiler's so good, their programming model is so good. Like you can write, I mean, I guess this is why they're so popular. You can write basically bad code and still get performance.
Isn't that nice? Also want
Yeah.
people to write okay-ish Tinygraph front-end code and still be fast.
Yeah, I mean, we want to replicate that property of the NVIDIA code. But the
Mhm.
DSP, even when I'm done with this DSP contract, yeah, we're going to get MobileNet V2 to be fast, but it's going to still take a lot of work to get everything to be fast on the DSP. But almost everything I'm doing here is universally applicable to speed, period. Making pad work, I think, is just a universal. It helps
Mhm.
everything.
Yes, I don't want to see that bad happening.
Yeah, and then these quantization rules also should work for, it should be pretty easy to get NVIDIA tensor cores working. As well. So we could use int8 tensor cores, which will get us the massive gigaflops, massive
Mhm.
teraflops, 600 on 4090s.
Sounds good. Okay, moving on. I gave a like talk or went through the Tinygraph code base yesterday. I put a slide in documentation channel. I think people are generally pretty excited about works like this. I guess the main takeaway, people in the group are interested in web GPU and porting things to web. And I mentioned about the export and the tiny chat demo. So I think that definitely will be one way people interact with web GPU and with TinyGrad. Like they can load the Onyx model and run it in web.
Great.
That's the main thing. So for
Yeah, it'll
birds,
be If we're the
Sorry, go
go-to
ahead.
library for that, that's great. That's a pretty big niche.
Yeah, I think web GPU because it just runs on people's power in browser and they don't need to set up their environments and stuff.
This is why the web took over.
Yep. So we can talk about that more in the web GPU part. Bird, so I run a bunch of runs, I fix some regressions. Now I think our speed is auto speed is comparable to our last submission. Per step is 2% slower. I think some of it is search because we introduce like different shapes of tensor core. We also remove like multi-output. But the kernel looks similarly bad, and a lot of time are spending on really just attention. So two main direction that improves BERT would be better kernel fusions and like better understanding where we spend in memory. If we can fit larger batch size, it will certainly be faster. So
Yeah,
that's my
I suspect that we waste a ton of memory storing the wrong D type. Like we're storing floats when we should be storing float 16s.
let's cast before view. Yes.
Yeah. And all variants. There's tons of variants of cast before view. So
So
I just pack
basically from one realize to another realize. Basically, you can pick the thing in the middle that has the smallest D type and to store that.
Yeah, we basically need that logic. We have that same, it has the same problem. So I wrote that don't realize expands and just put manual contiguouses in the DSP stuff, but it's not good. It's not right. The schedule should figure that out.
And there's a separate tricky stuff. It's probably specifically to Tensor Core because we can only trigger Tensor Core if its parent is safe to pad. So we pad that thing and do Tensor Core. But you can imagine if we up the kernel at a runtime, maybe your Tensor Core previously can be triggered, but no longer can be triggered. I don't have a good solution for that, but that's the main reason why if we just blindly put don't realize a lot of things get slower because Tensor Core no longer trigger.
So there's a way to fix that. What you can do is you can inject a where before the tensor core to re-inject zeros wherever you padded.
But what if it's not a clean pad?
It doesn't matter. Like the if something is unsafe in pad, like let it be unsafe in pad. Let every element wise. This is the real solution to unsafe pad. What you can do is you can have a big chain of things. The worst
Or you,
unsafe pad is going to do is end up with something non-zero, and then you stick a where at the end of that and put the zeros back in. Yeah,
Oh,
this
okay.
is the universal solution to unsafe pad.
I can write that. Okay, that sounds very good.
Yeah.
Okay, great. Yeah, but okay, that sounds good. Yeah. Anyway, BERT is important because BERT is very clean. It really is the same thing as other like LLM training. We just need to make that like 10 kernels fast, and it will be fast. Uh,
Yeah, attention fusion. Attention fusion is going to be harder. Like even softmax fusion is sort of beyond what we can express right now. But focusing on these pads and the D type things, I think is a very good place to focus. And I'm struggling with the same stuff right now too for the DSP.
okay, sounds good. Yeah, I think we can at least do the so the first part of softmax fusion is really similar to a norm fusion. Like you do a reduce, then you subtract that, or you do a max and you subtract that. I think that thing should be doable. Maybe after the next schedule clean up. But
If
the
you think
whole
you know
thing,
how to,
I don't know how to do it. But the whole thing
okay,
of softmax fusion is similar to argmax fusion. Like you want to track a value that depends on another value that's being looping over that we cannot express yet.
I looked at softmax fusion, and I posted one of the graphs. The main thing that you have to do is like you have this reduce, and you have to put the reduce in locals. It's the genericization of group.
Oh, so there are two soft max optimization I was thinking. So one is the same kernel that we have now, and it's the thing you just described. But there's a way, and we probably need to do this. So it's more, it looks more like argmax. So it's a two-pass algorithm on softmax. That's a different kernel than what we have now. And I think we need that for flash attention because flash attention is basically that.
I mean, we can't even do simple reduce group.
Yeah.
But yeah, no, I know the argmax thing you bring up. I can come up with a solution to that if you think you can do the softmax reduce one.
I need to learn a lot more about scheduler first. Okay, I think it's a good time to move on to scheduler.
Okay. So we have kernel up now. Reload is gone. You can basically like let the assigns depend on other assigns, which is I think a nice refactor. It did regress speed by 10%, but overall it's a simplification. It does set the stage to move on to the becomes map refactor. So what we have to do really for reorder expand is the reconstruction of movement ops from views, like genericize that logic. We have that logic.
Whoa! That's impossible.
I'm not gonna do that. I'm not gonna sit and do math. I'm just gonna brute force it from the for the tensor map. That's the plan.
So when you say you need to reconstruct, it's really just reconstruct, right? You are not arbitrarily creating a view and try to figure out a set of movement ops.
We
So
know the movements,
yeah,
sort
so
of. Like
if it's coming from some source that we are already aware of, at least you can have a mapping between your set of movement ops to the view and just look up that. I think that's fine.
Oh yeah, just use a cache if you want to do it in the same function. Just cache like whatever you turned into a view, and then you can re-expand that to movement ops.
it's not that simple. There's edge cases, but like I'm going through the edge cases. Think that should be enough to like enable all of these. So yeah, I'm gonna merge your reorder expand this week. And I'm gonna start work on more fusion stuff in the scheduler.
I'm really excited for reorder expand because that's cast before view. That's all of this stuff. Oh yeah, I forgot I did this week. Yeah, that expand, the early reorder expand is basically the prereq for softmax. That's how I ended up there. Oh. But great, yeah, no, I see you got the kernel thing merged too. The program renderer. You're very fast with those JavaScript things. Yeah, so I'll get that merged tomorrow, and then I'll finish up kind of my refactor of rewriter and all of that stuff into something that I want to call flow. Oh, did you see what I said about the schedule, like the create schedule from names?
I haven't done that. Yeah. I need to do that.
Yeah, but you understand. You understand like what the idea is, and then also having something in graph rewrite where I can like name the rewrite.
Yeah. I did merge the fast viz though. You can. I don't know if you've tried Beautiful MNest yet with the new viz.
Oh, I haven't tried. I see the way that they like light up now when they load. It's really nice.
Yeah.
Yeah. No, that's awesome. Great. So you're telling me Beautiful MNest works right now if I try that in Viz.
Oh, one thing I forgot to mention. So during the talk I gave yesterday, people are also excited about the fact that you can just debug equals to 2 and debug equal to 4 and see the source code. And also viz equals to 1 is pretty nice. or like
Yeah.
understanding what's happening in Tinygraph.
Oh, I finally made debug equals 3 usable too. Debug equals 3 will show you the buffers for each kernel. It doesn't print tons of UOP spam, it's just the buffers. So that
Do we
should be
print
useful for
that by default in like 5 or higher ones, or no?
everything that prints in 3 prints in 5 or higher.
No. I mean, but you remove the ones that print the modify UOP, right? And we don't currently print that anywhere else.
Oh, yeah, I removed that. If you want that back, I think maybe someone put it back. If you want it back, just throw it in, but not 3.
No, yeah,
Five is
yeah. So I added like row at AST. I find that useful in like writing tests, but my issue with the big UOP was it can get very big, very long, very easily.
Yeah, yeah.
Debug equals to 4 code is kind of always short, and at least it's compact, and it doesn't bring like break my indentation on my screen. Okay, oh, that's great. Yeah, Viz is
Fast is
great.
a stretch here. It's taking about 20 seconds to load.
Does it work?
Oh, it's still loading. Nothing yet.
Okay.
Oh, but can I click over to the other one? I mean, I guess what I'm also fine with is if I can just click away from it really fast. No, I
I'm
don't
very
see how
sad
to.
that yeah, the issue is with the rendered with the graph that we have. So that's like the last bottleneck on this whole thing. It's rendering SVGs, and SVGs are just blocking the main thread. That's slow. I have something that uses the GPU to do it. That will
Yeah,
fix
but
it.
a lot of times with UI stuff, like the problem is right now. So I run on Beautiful MNest. I click create schedule with vars1, and now the thing is hung. I have no feedback. I have a black screen. I have some feedback in the Python window, but if I click over to something else, it looks just entirely hung. Now it let me click away to something else, but nothing's loading still. Because it had to wait for the Python to finish the kernel thing, and then it finally loaded. But you see what I mean? Like, there always has to be something moving on the screen telling me what's going on. Every time I'm at a black screen, like, I don't know if I can click other things. I don't know if I can. So yeah, like run Beautiful MNest, click that. Like, I want to have something on the screen in like a second after I click create schedule with vars1. I don't really care what it is as long as it's responsive. Like, if we can't render the graph, we can't render the graph, but that responsiveness is super important. Yeah, it's kind of annoying that like the first, like when you expand it, it automatically loads the first one. That makes a lot of sense, but the problem is the first one is this huge one on the schedules. So there was like my hack to just like not make the first one the main one. But yeah, whatever it is, here's the test to do. Run Beautiful MNest with Viz, and then click that create schedule, and then I want something on the screen in a second.
You want the loading bar?
That's better. I really want something that doesn't make the whole UI unresponsive. Like, even if I could just click on it and then click away to something else, and that is under a second, I'm okay with that too. The problem is right now when I click it, it takes 18 seconds to return that thing from Python. So I don't know if there's a way to like interrupt it or.
Yeah, I think I
This,
know what I need to do for that, but like sort of all comes down to the fixing the graph renderer. That's like blocking everything at this point. It's like
so
bottlenecking the rest of the part.
it actually blocks the main thread.
Yeah.
And you can't get inputs to get you can't cancel it in any way?
Not really, it's not like a worker or something. It's just like a black box library that's calling some daggery thing. I have
What if you
something
do
that
like
moves it to a work.
yeah, I'm an old school JavaScript guy. What if you do like a window.set timeout?
I'll try it. Yeah.
And then some way to interrupt so the Python thing takes 18 seconds. Can that be interrupted? I'm sure that can be interrupted. Like interrupt the Ajax or whatever.
Yeah, I refactored it to like stream stuff so you can actually just cancel it midway.
Great. Yeah. I mean, just like all I do, 90% of what I do whenever someone like asks me to like test their thing is I'll load it up and they'll just click around really fast and be like, I broke it. And then after I click around really fast, if I didn't break it, I'm like, okay, this is good software. This is something I want to use.
Okay. Sounds good. We know what needs to be tested, and we can move on to move on.
It's awesome that this works at all. Like this is so cool that this like, okay, fine, it takes 30 seconds to load, but yeah, great work making this work.
Cool. I will also try it after the meeting. Okay, let's move on to driver.
Yeah, so I'm mostly focused on the BGPU this week. So yeah, actually we got only 4 versions to the same. Like, okay, so we also can send TLPs now, like on the 23rd, but they're still slow. So yeah, so I'm just looking into firmware, and so yeah, actually they use I found and localized all this stuff they set up NVMe queues and how they talk to the NVMe drive. So yeah, actually they also use TLP to set up to write some information into the bar. So, but after that, it looks like they set up queues, and these queues, it looks like queues are in their memory, like on the controller itself, and it looks like NVMe has access to, to this memory. So yeah.
Wait. Sorry, I'm not totally following this. So first off, do we have the 24 to where the 23 is? So does the GPU on Tiny 10 work? Can I use that? Even if it takes like 6 seconds or whatever? Or 6 minutes?
So I'm not sure about Tiny 10, but on the but yeah, we can send the TLP. It's just the state where we can. So yeah, it's actually the same state as the 24.
Well, yeah, but I'm on Tiny 10 right now. Do you have a branch I can try?
Yeah. I mean, yeah, actually, I mean, there is pull request to try, but it's just not loading them completely. It's just
So I'm
it
checking
just
out
writing
GPU.
something.
I'm checking out GPU USB on master.
Yeah, this one.
Cool.
So yeah, it's actually support all these TLP requests for the 24. So yeah, it can do the same thing as 23.
I'm rebasing. Let's hope this rebase works. This rebase does not work. I'm so bad at Git. And okay, there's just a conflict in the imports. That's easy. So then,
The way actually,
yeah, do you think it's doable without firmware mods, or do you think we're gonna have to change the firmware on the thing?
so I'm still looking into that. I just I'm not really sure how about the USB subpart of this firmware. So actually how it could talk to the USB controller and just take all the data. So, but so yeah, I'm gonna look into that. And but I think, but yeah, I think yeah, even if we don't find anything good, I think we can just modify the firmware and actually move all
Yeah.
this logic that we have right now into the firmware itself, which should be a lot faster.
So I understand modifying the firmware will make it faster, but the question is how fast. Like, sure, we'll definitely be able to do whatever this USB transaction is a lot faster. But I worry that we're not going to be able to get like multi-gigabit speeds, which is really what I want.
Yeah, I mean, actually, but from I measured right now, there is some internal function already which is implemented in the firmware which can read some external memory. So and the speed of this is about 1 megabyte a second.
1
So
megabyte
it's
a second.
yeah, it's not very fast. And actually, I think that matches because I found that the controller runs on 25 megahertz. So it's approximate. If we copy like 4 bytes each, yeah,
Yeah.
it's about.
We
So
we got to
yeah,
set up some way to bypass the controller entirely, right? Like we have a lot of control of the GPU too. So if we could get the GPU to pretend to be an NVMe device, like there's no way it's using like PIO is the old term for it, like programmed IO, where you do the copy one at a time. There's no way that microcontroller is doing basically a mem copy for an NVMe drive. There has to be some kind of DMA you can set up.
mm, so actually, yeah, that's interesting. I mean, yeah, I mean,
So
I
I got
found like, yeah, all this in VMD logic, yeah, like the addresses they set and the queue they set. So, and addresses actually look a bit strange, but actually, as far as I understand that, the whole idea of the MVE is just it's like can do DMA to the device. Oh, uh, actually, yeah, okay, I'll check that. I'm not sure
I
what
mean,
addresses they set there again, but
yeah, the NVMe has to be fast in both directions, right? Like when you use these things with NVMe drives, they're fast on both read and write.
yeah, yeah, yeah.
Okay. libusb equals 1, AMD equals 1. Okay, I need to apt-get install libusb.
Yeah. Yeah.
Does
So maybe
libusb
it's
talk
not
to
in
the
the base.
kernel?
Maybe, huh?
How does libusb talk to the kernel?
Um, that's a good question. I don't know.
Oh, so okay, it's not. I don't have libusb 1.0. Do you not have to apt-get for that? Oh, libusb 1.0 dev.
Yeah, maybe that one.
Okay.
So actually, yeah, maybe this branch is not in the best state right now. I
Okay.
don't know if
Is there any way anything I can test? Yeah, if I run it right now, I get, yeah, this branch isn't right because I'm getting ASM got an unexpected keyword argument is 24. That.
Okay, yeah. Yeah, okay. I mean, okay, I'll update this branch today to the working state. And okay, yeah.
Yeah, what I want to do is even if it takes a long time, even if it's still with slow transactions, I just want to see this work on Tiny Test. With the 20. So it's an ASM 24 and it's a 7600.
Uh-huh. Yeah, okay, okay.
Yeah, and then there has to be, before we modify the firmware, I really want to understand like how this NVMe drive is doing it, because any modification to the firmware is going to be limited by that 25 megahertz clock speed that you're talking about. Whereas if we can actually get the DMA to trigger off the thing, DMA is fast. Like it has to be, because this thing can plug into a MacBook and get 40 gigabits. You can even get 20 gigabits on just USB 3, 3.2. So yeah, there's got to be some DMA way to do this that isn't. What else could PCIe be besides like a DMA to an address?
Yeah.
Cool. But yeah,
I mean,
I'll check this again
yeah.
tomorrow.
Okay. So update the branch to a state that can be tested on Tiny 10. Okay. Let's move on to Tinycorp.
Hi, hello. I
Hello.
don't have much progress to report. I have been mainly working on some tests and proof of concepts, but anything worth upstreaming. I have some questions, though, to which is the correct abstraction. Like, is there another use case I could take into consideration to make this abstraction generic? I don't want to overfit into the AMX implementation.
Yeah, so it's anything where you have a it basically almost should be the same thing as define local. Like
Okay.
whatever abstraction you use should actually kind of work with define local as well. And you can have a flag on define local if it's like a special like local, because that's basically what you're doing. You're loading and storing from a local, which is the AMX register, which is free. So yeah, it's the same thing as define local.
Yes.
And then
Sure. Continue.
yeah,
Sorry.
yeah, and we'll see if these. I'm not sure. Flamet says the 5090 doesn't have it, but it seems like tensor cores are going to start to have stuff like this. So yeah, it's the same basic idea as local memory. And if you really want to go far with it, like unify the concept of like all the buffers, right? So we have define ACC, define ACC, define local, and define AMX should all kind of be one thing. Define ACC is really define register.
Yes.
And then assign a store. And then you should load as well. Yeah, that needs to be refactored. Define ACC. It should be the same thing as define ACC.
Yes, like one problem I encountered on the AMX is that it has a fixed continuous access size. That's why mainly I was thinking in like a more complex definition, like a data class with size, continuous access, and D type. But
yeah, if it can only be accessed as one thing, just make that the D type. Make that the D type and don't support JEPs on that.
Oh, that's a good idea. Yes.
Cool.
Thank you.
That's good. Any update for Onyx? Okay. Implemented tension, blah blah blah.
Wait, how is it past 201, failed 49 in the top 100 Hugging Face repos?
They're testing 250.
Yeah. Oh, multiple per
Oh,
repo. Alright, cool.
Yeah. So 250 in total. So if it's a numerical issue, it's probably fine. But is there any main thing that is not implemented?
I'm not so sure it is fine. Depending on what that means for the numerical inaccuracy, because that thing is really, the quantized linear is really fidgety. And like it's using a round right now, and I'm not 100% sure that's right. So I have another thing that also works besides the round, but if you get this a little bit wrong, it like degrades accuracy. So I'm curious like what exactly those representations are. It's also possible that the Onyx runtime implementation of quantization is numerically inaccurate. There's all kinds of. I've dove deep into quantization. I guess it's fine if they're not. It's not really the Onyx being broken, but there's a lot of
Yeah, so
subtlety to
my point for fine is fine to make a PR and merge this into master, because I know you are working on the context stuff. That can be like fixed
Sounds good.
independent of this the script and for this bounty. I think the
Done.
scope of a bounty is we get things merged, we test the popular repos, and if there's no like obvious thing that we don't support, I consider that dumb. Then we can fix specific for these quantized stuff.
Yeah, agreed. I just want to say that I think the quantize things are real bugs, but I think they're outside the scope of the bounty. I agree.
Cool. Blow up after multiple rounds of quantized and dequantized. Yeah, I think some of these would be interested if you also like mark or have a specific way to show these errors in your script. So like known numerical errors, you can test or fix and compare to see if it's like our next runtime has an issue, because we know sometimes it can have issue, or if it's our implementation that's incorrect. Cool. Okay, web GPU split into WPMAD first.
Yeah, so on web GPU front, yeah, the F16 stuff has been merged. There was a refactor that's merged, and I also did synchronize because testing speed stuff, I got really interesting results, like faster than Metal on Torch. So it was suspicious. I checked with Nimogen, and yeah, it was missing synchronize, so I added it. Then so we bumped into this issue where we tried to split DIMMs because the global DIMMs became too large to fit in WebGPU limits, and it always errored out. Now it's solved. It has been merged. So yeah, WebGPU is in a lot better shape than it was last week. So now I will move on to actually working on the export model stuff.
You fix the library path?
No,
really
that one
want it to
not
be
yet.
okay.
Yeah, because I will fix it. It's just that when I brew install it, it finds it, but maybe that's something so you brew install it and it doesn't find it, right?
Yeah. So brew install in the opt/homebrew/lib, but my ctype.find library it's not in my default path. So I can either add it to the path or I manually specify the path. But the main point is that in terms of the arrows we are giving is not accurate. I follow the instruction, but it's still not working.
Yeah, I will fix it then first, and after that export model stuff.
Cool. Oh, that's nice. It's nice that you bring back the split in test and stuff.
Yeah, it was driving me crazy that everything worked and benchmark was always just like timing out, and it was because group DIMMs was not just for so at first I thought it was the original limit DIMMs was just for when the DIMM, like you have a 4D global DIMM and want to limit it to 3D, but it was not just for that. So it can also group together DIMMs when the global max LAN is equal to the your DIMMs length. So and it errored out because on NVBeam it chose the split DIMM strategy, which is slower. So that was the reason. But now the two work perfectly well together. So it solves the web GPU stuff and it works fine on NV as well. So yeah.
Great. Do you know what's the limit for buffer numbers for web GPU kernel now? Is it 10
It's
on
10.
Linux?
It's 10 or 11. I think it's 10.
Is there a way that we can increase that?
So I don't know why 10 actually, because like WebGPU is a layer on top of Metal if you run on a Mac, and in Metal you don't have you're
Metal
not
is
limited.
32, right? Like 32 or
Yeah, but
31.
I think I think it's larger than, so on Metal I think it's larger than 10. It's more like 20 or more. So, and
Yeah,
in the
it's
original
32.
yeah
32
so
on
it's
Metal,
much,
I think.
yeah it's much larger. So not sure why they limit it like that. The thing with vGPU Pi that we previously used is there is no such limit, but the trap there is, so you think you're fine, and then you export your model, and then you run it in Chrome, and then you see that, oh, it doesn't work. So what we see now is like the reality, and vGPU Pi was not exactly WebGPU, but I don't know. I try to, so you can request these limits. You can try requesting larger limits, but for this buffer number, I couldn't request larger. If I try to request larger, it errored out. So it seems like it's 10.
Oh, that's fine. Just curious. Cool. Yeah, so for the Tiny Chat, there's a new implementation link in general channel. Who, you want to say something?
It's impressively fast on my Mac. By the way, if anyone in here is a designer who wants to mess with the CSS of this, like when I make the window smaller, there's no padding to the edge of the chat bubbles. I'm terrible at this, but like if someone here wants to fix up this CSS, great.
Setting up the code for merge sounds good. Yeah, the demo looks, demo works fine. I also tested it on my phone and my browser, and seems to be working.
Yeah, we need a designer to make this like look nice.
What do you mean
If
that
anyone in
looks nice?
here wants to.
What was Perry would be sad if you say it doesn't look nice?
Oh well, we've moved far away from the original Woes parrot, the red and the green. Half of me wants to just copy ChatGPT exactly. No, I think it's fine. I think we just
I heard LLMs are pretty good at copying style nowadays.
But yeah, no, it's fast, it's local. The tokenizer is uncached though, so it has to go to the internet every time to get the tokenizer. Any reason that can't be just shoved into XDB too? Yeah, I mean, again, you've gone above and beyond what this bounty is. This definitely already qualifies once it's merged, but it would be great to have it work without internet. I think you mentioned that. So if you just go to it once and yeah, no, I think when this is like final and we have good design and this is good, I think that this is going to hit the front page of Hacker News. And this is your accomplishment. This isn't TinyGrad's accomplishment. This is like the use of TinyGrad as a library, which is awesome. And I think that there's a lot of excitement around WebGPU, and this could be like a first sort of niche that we really just try to invest in. It's exciting. Let me know when you want me to review any of the code. Breaking things up into PRs is always good. Independent standalone features is a lot easier to review than lots of lines. But lots of lines can be okay if they're not. Like lots of changes all around the code base is impossible to review. Let me see what the PR is now. Oh yeah, it's very few changes to the actual code base. But those llama changes should be a separate PR. Yeah, like all the changes to Llama 3 export model and Llama should be a separate thing. And then like all of your JavaScript stuff can I will review it, but The stuff that I'll review the most carefully is stuff that changes existing code.
Nice work. Okay, let's move on to other bounties. RetinaNet.
Hello. So for RetinaNet, I've been trying to figure out where the lands are coming from. So I've been working on a very sample set of the data set. And at least for this one, because there's two losses involved, the classification loss and the regression loss. So on the classification loss side of things, on the smaller set, it will actually NAN out, but on, I guess, like a bigger batch size, it's the regression loss that's NANning out. So I'm trying to focus on the smaller set size of the data set, and for some reason, the backbone model, which is the resonant size, is throwing out some NANds later on once it has trained a few epochs or so, probably like I think more than 20 epochs. So I'm trying to figure out where that is coming from. So still investigating on that. I did find some bugs along the way as well, just kind of like in some places here and there. So that was a good time that I was able to address those, but mainly focusing on figuring out where the NANds are coming from now.
Now, what's your process look like figuring things like this out? Is it like, so you mentioned you train in float, so it's less likely to be like below 16 issue. But other than that, how do you like debug this? Because we want to kind of bake this into Tinycorp as a debugging feature. So just curious how you are currently doing it.
I think definitely like debugging with a smaller data set did help a lot for me. Obviously, so that my I guess my cycle time on that is actually pretty short. What else have you been using? I think mostly that and the and really just kind of digging through the model. I don't know if there was, I guess, any other helpful tips that I had there.
So for BERT and for ResNet, because I think it's BERT has the global norm clipping stuff. So it clips the global norm of gradients. So for that, I just output it as another value in addition to the loss, and I also print that in WMB, and you can see the global norm should be increasing gradually, then decreasing as the learning rate gets smaller. So maybe something similar to that will help. I don't know if you have similar normalization numbers in your. So one obvious thing is you can like print the scale of your gradients, right? So if gradients become too large, then something is broken. Similar to that.
Oh yeah, that's definitely a good point. Yeah, I also did actually do something like that, like similar to what you said, just kind of printing out the values along with the loss for the certain parts of the network. And that's kind of like where I found out where the backbone itself was throwing out the NANds, not the actual classification head in this case that was causing it.
Okay, sounds good. And you shouldn't have any issue with accessing the machine.
No, not at all. Not at all.
Great, good to know. Okay, let's move on to graph rewrite 2.0.
Hi. So it's I guess it's almost over. I did the name assignment, and it's at 2x speed, but 4x is fairly straightforward because a lot of the time is spent creating match sets that already exist.
Do you have a working branch for this that passes tests?
No. So one thing that's left is any source, but I essentially removed just the single use from symbolic, which doesn't really affect the speed because I'm just trying to measure the speed. Any source depends, the implementation of any source, and I guess also the permutations depend on like how I do the name assignment. Because right now, I just have to like deduplicate, or I guess duplicate. So if we have, for example, an add,
You just do all the
if we had
permutations.
an add of, yeah, because the name assignment needs to be a straight thing where we can't have like more than one possibility, because then we would have to match again.
Got it. Are
Yeah,
there any? So
I think it's possible to get 4x.
great. Yeah. This might be the you might be making the most money per line in TinyGrad's history if it looks like the same sort of 60-line thing.
I am really happy with the way it looks. It's not going to look as nice, I guess. There's a little bit more because for the match set creation, I also check the binds. I check if the variable bindings are valid or not, and
If the
that's
transition
a
doesn't
couple more
exist.
lines, and so yeah. But also, I wanted to say 8x is definitely not possible. I don't think it's possible anyways. But with this approach, it's not possible because just the time to actually do the lookups, the time to hash the tuples, that alone takes more than what would be an 8x speedup.
Yeah, I mean,
And everything takes
4x
so long at these speeds.
4x is a great victory. I think with some of the maybe to get more speed beyond that, we'll have to rethink maybe what some like. I'm always open also to like changing the spec a little bit. If like any turns out to be really slow, well, maybe we can't use it or we have to implement it in a different way. But 4x is a huge victory.
I guess one suggestion is that currently any is essentially it just creates a pattern that's never checked, right? Only the sources are checked, and that does allow you to kind of nicely, right? 'Cause essentially, any is the same as a permutation in the sense that any source is valid, but it's not done like a permutation, right? It creates this extra sort of pattern, and it would
Oh,
be
yeah.
nice if it didn't, right? It would simplify stuff, but I guess you
I
can't
actually
then do the nice stuff that you can with any, where
I
you can
did
just have any in one of the sources.
I did this once where I replaced the permutation logic using any. Like I was like, oh, this logic's in here twice, but it made everything way slower, so I had to revert it. You're saying that the permutation's hard to support or any is hard to support? Because the permutation is a subset of any.
No, it's just that 'cause now I guess I'm thinking about this, but any creates a pattern that is never actually checked, right? It skips the check for itself and only checks its sources. So if you look at the code, the way it checks for permutation, it just has an any, right? And
Oh
then
yeah,
inside of the any is the all. But
yeah, but
then you couldn't do that with upat.any, right?
you could re-implement that however you want. Upat.any is just a way that I wrote it to make the old matcher work. You can totally change that logic that's in any to actually construct all the permutations of the pattern. If you want to construct all the permutations of the pattern at any time, I'm totally fine with that.
Yeah, the only thing is that I had and like just change the interface because but the thing is upat.any does allow you to do some nice things. For example, you can say that the first source is an any and then the second source has to be something else, and it will check, it will automatically do the, for example, let's say that any is any of three, the first one with the second one, the second one with the second one, and the third one or the first one, right? You can't do that if you don't have that nice sort of formatting. If you actually have to, I don't know. I guess I'll just I'll think about it. Whatever.
Is the case you just described used anywhere in TinyGrad now?
Yes, it is. It is used. I check. It's used in the rewriter. The only in symbolic, it's used in that.
We use any rarely enough, so like one thing we could do with any to replace it. I thought about even writing this when I was writing any, but then I wrote that thing and it wasn't that slow. Like if there's like say there's like 3 any's inside of a pattern, and those 3 any's each have 2 things, I'm okay with basically just creating 8 rewrite rules. Right? Like the any is just syntactic sugar around creating all the possibilities of the any. If that
I'll
makes
think
sense.
about it because
Like
it's easy to fix or it's easy to implement. It maybe looks a bit ugly. I guess it's I was thinking, but I'll see how it looks, and then I guess I'll think about it more. But I haven't actually implemented any, but it's not difficult. It's just I delayed it because I just delayed those decisions because it's not really relevant for the speed measurement, which is what I'm sort of interested in.
Agreed. Yeah, let's get tests passing, even if the any tests all fail. Let's go
Also, a couple other things. I think this is a small thing. The top-down rewrite and the bottom-up rewrite, I think they should be switched, the names, because usually bottom-up means leaf to root, and top-down means root to leaf, and they're switched currently. It's kind of confusing, I guess.
Yeah, I mean, I always think of sinks as the bottom. I don't think we should, because like I understand that that's usually how it is in the other kind of in like a normal like tree, but the sink is at the bottom or on the right in this graph. So bottom up is from the sink upward, and top down is from things that feed into the sink down.
But if you print it, it prints the sink first, right? Basically, mean in Viz.
The print is backwards. Yes, the print is backwards.
Okay.
Take a look at it in Viz. You'll see the sink on the right.
And also, is there a reason why the rewrite cache doesn't persist across kernels? That I did that, and it's a speed up, but it's not that substantial.
Yeah, let's not do that yet. We'll get there. So the two reasons we haven't done it yet. One is any rewrite with a context, you can't do this. So you're going to have to support non-cached rewrites anyway. And two, I'm not sure what the memory implications are. Like, what is the free policy on this cache? Is it never free? Is it LRU? So yeah, that's definitely another project I wouldn't touch it for this, but I've certainly thought about it. And like, yeah, like a whole lot of the rewrites in TinyGrad will affect a whole lot of the caches in TinyGrad will effectively become the graph rewrite cache. We have like the method cache. And the method cache could basically be a graph rewrite cache at some point.
Anything else you want to add for graph rewrite?
No, that's it.
Okay.
Great. Yeah, looking forward to seeing it pass the tests.
Yep. I think is there other active bounties that I'm missing? I think that's it.
BT1G isn't here, but there's the LLVM backend bounty that's being worked on. That's pretty cool. Yeah, we can remove co-manager, and then that officially removes every piece of AMD software from our stack. Our driver is not AMD. Our compiler is just it's LLVM. It'll be just LLVM. Like it's normal LLVM 19 upstreamed. So sure, AMD might have still wrote the code, but it's upstream LLVM.
Great. Yeah, looks nice. Okay, I think that concludes the meeting. Thank you, everyone, and see you next week.
Bye.